All right, let's see. For this guy, we have a fairly theoretical question. We are given the graph of f, little f right here. And we're saying, suppose we know that we know what the integral is from 0 to 2 on f of x. How could we write an expression for the integral from -2 to 2? So actually, because this is an even function on this interval, we can just state that this guy is equal to twice the integral from 0 to 2 of f of x dx. So number 2 says, suppose we know the integrals from 0 to 5 and 2 to 5. And let's see, I need to bring this down to get my... Okay. I know the integrals from 0 to 5 and 2 to 5. How do we get the integral from 0 to 2? Well, I think I can just subtract, because I know from my properties of integration that if I integrate from 0 to 2 and add that to the integral from 2 to 5, I am going to get the integral from 0 to 5. So that means that the expression for the integral from 0 to 2 is going to be the entire expression from 0 to 5, subtracting off the expression from 2 to 5. So then next, suppose we know the integral from -2 to 5 and the integral from -2 to 2. Well, do you remember in number 1, we said that the integral from -2 to 2 is twice the integral from 0 to 2. So that's going to be helpful because we're looking for the integral from 0 to 5. So we need to subtract off, let's see, what we also know. I'm thinking about a better way to say this, because we know through symmetry that the following holds. We know that the integral from -2 to 2 is actually equal to the integral from -2 to 0 is equal to the integral from 0 to 2 by symmetry. So actually, if I take the integral from -2 to 5 and I subtract off the part of it that is from -2 to 0, I'm actually subtracting off of it the same as the integral from 0 to 2. So I'm running out of space to write this, but let's see if I can fit it in over here on the right, that the integral from 0 to 5 could be stated as the entire integral from -2 to 5 of f of x dx, and subtract out just the integral from 0 to 2 f of x dx, which we also know. That will get us what we need in the end. Okay, so then not last. Oh boy, how am I going to get all this in? Okay, so suppose we know, I'm trying to think of the one I just did. Suppose we know -2 to 2 and 0 to 5. How can we write an expression for 2 to 5? I feel like this is almost just like what we did, but hold on. I know what we do. We're going to take the integral from 0 to 5. We are going to subtract off half of the known integral from -2 to 2. And that will get us the actual integral just from 2 to 5. It's getting very tight to write all of this. Okay, now suppose we know the integral from -2 to 5 and the integral from -2 to 0. How do we write an expression for the integral from 2 to 5? We'll take the integral from -2 to 5 and then subtract off twice the integral from -2 to 0, again using symmetry. That will get us what we want. And now finally last, suppose we know the integral from 2 to 5 and the integral from -2 to 5. What is the expression for the integral from 0 to 2? Well, I want you to take the integral from 2 to 5. I want you to subtract off the integral from -2 to 5. That is going to leave you with the entire integral. 2 to 5. I want to do that reverse. I want to take, let's see if I can fix this. I want to take the integral from -2 to 5 and subtract off the integral from 2 to 5. So I'm subtracting off a part of what I have. So take from negative 2 to 5, get rid of negative 2 to 5. That will leave me with the integral from negative 2 to 2. And then what I can do is cut that in half. Oops, cut that in half to get what I actually needed. That was pretty complicated though.